Alright, here we have a right triangle, and we're looking for the sine, cosine, and tangent of angle B, which is right here. So, when I'm labeling, the side across from the the right angle is always the hypotenuse. The side across from the angle is always the opposite, which means the side left over is left to be the adjacent. Now in this case we're missing the opposite, so in order to figure out what the opposite is, I'm going to do 5 squared plus x squared equals 6 squared. So we got 25 plus x squared equals 36. Subtract 25, x squared equals 11, and so we get the square root of 11. So the sine is the opposite over hypotenuse because we remember our mnemonic SOHCAHTOA spelled correctly. So the sine is the opposite over the hypotenuse, which is the square root of 11 over 6. The cosine turns out to be the adjacent over the hypotenuse, which is 5 over 6. And the tangent turns out to be the square root of 11 over 5, because that's the opposite over the adjacent. So the cosecant is going to be 6 over the square root of 11. The secant is going to be 6 over 5. And the cotangent is going to be 5 over the square root of 11. Now I'm not going to worry about rationalizing these right now, but if you wanted to, this one would have been 6 square roots of 11 over 11, and 5 square roots of 11 over 11 down here, because basically you bring the square root up to the top and it becomes 11 down here because you multiply the top and bottom by the square root of 11, but I'm sort of out of room to do it. Alright, so the important ones to remember are the ones that come from the special triangles of geometry, which are 30, 45, and 60. So in here, the opposite side from 30 is going to be x, which is, I'm going to write a 1 in front of it because really, and the side opposite the right angle was 2x, and the side across from 60 was x squared roots 3. And for the most part, we don't really need these x's here. And the 45, 45, 90 was 1, 1, and the square root of 2. So when I take a look at the sine of 30, we have the opposite over the hypotenuse. Well, opposite side of 30 is 1, and the hypotenuse is 2. When I do the sine of 45, I get 1 over the square root of 2, which when rationalized is the square root of 2 over 2. And for the sine of 60, we have the square root of 3 over 2. Looking at the 60 down here. So while we're at the 60 down here, let's do the cosine of 60. Well, the adjacent side is 1, and the hypotenuse is 2, so we get 1/2. Now the cosine of 45, and really it doesn't matter which 45 we used, is going to be just the same thing, which is the square root of 2 over 2. And the cosine turns out to be square root of 3 over 2 down here. So we got 1, 2, 3 going down this way, and we got 1, 2, 3 going up the cosine. And so for the tangent, all I'm going to do is follow what we had over here, 1 over the square root of 3. For 45, we got 1 over 1, which is just 1. And 60, we have the square root of 3 over 1, which is just the square root of 3. Now, if we take a look at this, we just have the numerator and the denominator right in here. The numerator comes from the sine, the denominator comes from the cosine. Well, when we do it with the square root of 2 and the square root of 2, that gives us 1 because it divided out is the same, and over here we have the square root of 3 over 1, which is just the square root of 3. I'm going to erase those blue circles now in order to make it so it's a little bit easier to read. And that was section 6-1, one triangle problem, and one in the 30, 45, 60.